Section 2.3 is on page 110. Talks about trigonometric equations. In this section, we're trying to solve a trig equation. Now, I'm going to break this into two lectures. One lecture I'm going to give you for next class meeting along with the previous section. And the next section, we're going to really cover the rest of this section and 2.4. So, solve each equation between 0 and 2 pi, and I'm going to take an equation. Let's say that one. That's the first equation. Now, there are a couple of things I need to discuss. So, one of them I'm going to leave for the next session. I just want to get this first portion out of the way. This is on page 160 in our book. So, the way you would solve any equation in math, you isolate the name by itself, right? So this is a trig equation, nothing different. I need to isolate the trig function by itself. I would subtract one from both sides. And I would divide by a negative. Now, we want to get this idea out of the way. There is a problem I need to mention. I'm going to point that out right now and elaborate on that in the next discussion. So for now, we're doing a portion, kind of like the easier version of those. If I label this to be 1 and this to be negative 1, and if I graph, oh boy, okay. So this is y equal negative 1, and this is y equal 1. And if I start a graph of a cosine, let's say start on the amplitude, runs down to the amplitude. This is one full cycle. But we know that this graph doesn't stop there. It continues indefinitely. And oops, okay. Oh boy. Alright, I'll get it right. Oh, come on already. Okay, here we go. If I take y equal cosine, that's the green. If I take y equal 1/2, if this is y equal a 1, and 1/2 is right there, if I draw the line y equal 1/2, we notice that the line intersects the graph of a cosine an infinite amount of times. Kind of like when you say y equal x squared and y equal 4. If you solve this system of equations, then you're saying x squared equal 4 by hand, x equal plus or minus 2. Graphically, y equal x squared, y equal 4, we notice they cross twice, one time at negative 2 and one time at 2. This is algebra. Here the problem is there are an infinite amount of solutions. Well, this first homework, we're going to focus on finding the first two every single time. And in the second half, I'm going to talk about this again. Let's get that out of the way now, and so this way I'll repeat. Once I know what this solution is, and keep in mind, this is one full cycle of a cosine, so this is between 0 and 2 pi, my unit circle. Once I know what this value is, guess what? I'll add a period and figure out what this is. I'll add another period and figure out what this is. Subtract a period, subtract another period. And once I know what this value is, if I add a period, I'll get the next time that will happen. And another time. And if I subtract a period, subtract another period, subtract another period, there it is. And it's no big secret. We all know what the period for sine and cosine is. Isn't that 2 pi? So if I know what this value is, if I add this value plus 2 pi, I'll figure out where it happens again. Another 2 pi, I'll figure out where it happens again. Subtract 2 pi, I got this point. Subtract 2 pi, I got this point. So here plus 2 pi, here plus another 2 pi, that is 4 pi. To the left, this is minus 2 pi, and this is minus 4 pi. And if I know what this point is, if I add 2 pi to it, I'll get the next time that happens, another 2 pi, subtract 2 pi, subtract another 2 pi, subtract another 2 pi. So I notice I'm really adding 2 pi, 4 pi, 6 pi, 8 pi, negative 2 pi, negative 4 pi, negative 6 pi, and negative 8 pi. And that's pretty much 2 pi k or n, where k is an integer. K equals 0, k equals 1. So k equals 0, I will pretty much get this first solution. K equals 1, k equals 2, k equals negative 1, k equals negative 2. This part, finding those solutions, I'm going to save for next class meeting. For now, we're going to focus mainly on how do you find those first two solutions. And to do that, I only need my unit circle. So I'm going to go back to this problem and say, all right, well, now that I got this graphically, and keep in mind, I'm only showing you the graph so that you would know what we're doing. You cannot use the graph anywhere. You have to use algebraic equations to solve this. I want to know, where does the cosine of theta equal 1/2? If I follow those 3 steps on every problem, I'll be able to work this out all the way. 1, I'll figure out what my reference angle is. Reference angle meaning in quadrant 1, the cosine of which angle gives me 1/2, and I know that's pi over 3. Second, I'll look at the cosine of an angle being, in this case, positive. I know that cosine is positive in quadrants 1 and 4. What is pi over 3 in the first quadrant? And how about in the fourth quadrant? And that's what theta will equal. So I just figured out for this specific problem, this right here is pi over 3, and this right here is 5 pi over 3. For every problem between 0 and 2 pi, if this angle is not, if it's standard, if it's not compressed or stretched, I get 2 answers for every trig function. I should know that by now. All sines, cosines, and tangent are positive in 2 quadrants and negative in 2 quadrants. So if I make a jump and I look at number 18, oops, if I copy number 18 down and I work this out, again, just like the last section, if you would like, if it helps, remember we added an extra section to this problem. So this was right there. And remember, you could always do this on a piece of paper, and that gives you all the reference angles: 30 degrees, 1, 2, radical 3, and 45 is easy to memorize. 1, 1, radical 2. Remember, this is pi over 6, which makes this pi over 3. So, if I isolate the trig function by itself, cosine of theta equals negative 1 over radical 3. So, plus or minus doesn't matter. If I follow those 3 steps, 1, what is the reference angle? Meaning, in those 2 triangles, the cotangent of which angle gives me 1 over radical 3, I know it's pi over 3 again. Coincidence. 2. Where does cosine of theta equal negative? Which quadrants? Tan and cotan are negative in quadrant 2 and 4. So, what would pi over 3 equal in the second quadrant? And how about the fourth quadrant? There it is. Again, I just found the first two angles. If I add a period for tan and cotan, the period wouldn't be 2 pi, it will be pi. I'll talk about that in class, next class meeting. For now, let's focus on this. And if I go back and look at number 16, I'm looking, where does cosine of theta equal -1? This is a special case. I don't need a reference angle for this. I know where this happens. Cosine of theta equals -1 on a unit circle. Well, that's only in one place, right there. That's when theta equals pi. And this is pretty much, again, a special case. No need to worry about that. Then what? What if I look at number 20? And what do we notice here? Again, it's a trig equation. I need to isolate the mean by itself. If I add 3 to both sides, cosecant of theta will equal 1. Well, keep in mind that's when the sine of theta equals 1. This is another special case that only happens in one place, and that is right there. So my angle will be theta equals pi over 2, and that takes care of it. Now, I want to do a couple more if I could. That would be great. And I want to tackle problem number 20. I was going to do 25. I was going to do number 26 now. Okay, well, let's see how this plays. I want to solve this problem. I could isolate the trig function by itself. This is quadratic, so you have a couple of options. And what happened when I square root both sides by using the square root property, which is pure algebra? That's plus or minus radical 3 over 2. So in this case, I want to know, 1, what is the reference angle? The cosine of which angle gives me radical 3 over 2, that's pi over 6. Secondly, where does the cosine of theta, and do you notice here it's positive and negative? Isn't it positive in 2 quadrants? And negative in 2 quadrants? So I need that angle in all the quadrants. Well, here it is pi over 6. Here it's 5 pi over 6. Here it is 7 pi over 6. And in quadrant 4 it's 11 pi over 6. Theta equals all of those. So in this case, plus or minus, instead of getting two solutions, I just doubled my solutions. And that happens if you have a plus or minus. So I am going to stop here. What I need you to do, I need you to do this portion of the homework before I move on and finish this up. There's the homework. I would like you to finish this part of the homework before I move on. And next class meeting, I'm going to go over the rest of this section and 2.4.